Objectives 1.4. Add and subtract complex numbers, multiply complex numbers, divide complex numbers, and perform operations with square roots of negative numbers. Okay? So first of all, here's what I want you to remember. Okay? A plus bi is a complex number. Why is that considered a complex number? Well, it has two parts, right? It has a real part and it has an imaginary part. Okay? Do you remember that? So here's what the rule actually says. Okay? It says A plus BI equals C plus DI if and only if, and I almost put that other sign because there's actually a mathematical abbreviation for this because we use it so much. If and only if. Okay? If and only if A equals C and, what do you think? Close. B equals D. Okay? So these two things are equal if and only if A equals C and B equals D. The reason it says if and only if is because it could also say C equals A and D equals B, right? Okay. Something else I want you to remember is, what is the square root of -1 actually equal? It's I. Yeah, absolutely. Okay, and we always write it like a little cursive I because we can't write italics, and that's how it would be if we typed it, right? Okay, so what does -1 equal then? What if I squared both sides of this equation right here? This would be -1, right? And this would be I squared. So some things to remember: I squared equals -1. Okay, and I equals the square root of -1. So adding and subtracting complex numbers is the first thing on our objectives for today. So let's talk about that. Okay, 2 plus 3i plus 4 plus 5i. Now, are these parentheses actually necessary at this point? So what it's doing is it's keeping the complex number together. They're saying this is the complex number and this is the complex number. But when I add complex numbers, which two parts do I add? Do you remember? Oh my gosh, I'm sitting here with my mask on. Please forgive me. Just got done with lunch. I forgot to put it back on. Sorry. I add the real parts, right? What's 2 plus 4? 6. What's 3i plus 5i? 8i. And then I'm done, right? What if I had 2 plus 3i minus 4 plus 5i? What would I get that time? Well, we're subtracting, right? So again, can I add in real and imaginary? When's the only time real and imaginary together work? Space Jam. Remember that? Space Jam is the only time real and imaginary together work. Okay? Otherwise, we have to just combine real and just combine imaginary. Okay? So 2 minus 4. 3i minus 5i. So minus 2i, right? How do you feel about adding and subtracting complex numbers? Feel okay about that? Do you remember that if your calculator is in the right mode, you can actually add them on your calculator? Menu, new, no, I don't want want to save the old on a calculator. 2 plus 3i. Remember, I don't use the I here at the bottom. I use the I that's under the pi key right here. Plus 4 plus 5i. See that it worked? Okay, subtraction also works this way. Multiplication and division also work this way. Division gets a little messy sometimes, though, so you got to be careful. Okay? But, I want you to know how to do it with your brain, too, not just the calculator, right? Okay? So let's do this problem then. 2 times 3 minus 4i. That's my favorite one, right? Remember why? My nickname when I was growing up, right? 4i? Okay. So how do we do this one? That was just a little joke. That's what they call me, though. Oh, sorry, zoom out. Yes, thank you. Sorry. How do I do this? Can you multiply real and imaginary? Yes, you just can't add or subtract them, right? Okay. So 2 times 3 and 2 times negative 4i. Minus 8i. Right? Can you do something like this then? 3 plus 4i times 5 plus 6i. How would you do this? Still distribute, right? So 3 times 5? 15. 3 times 6i? 18i. And then I have 4i times 5, so 20i. And then 4i times 6i, so 24i squared, right? I is not a variable, remember, but sometimes it acts like a variable, okay? It's not a placeholder for anything. It's telling you that's the imaginary part, that it acts like a variable in situations like this. I times I is I squared, okay? So I have 15 plus 38i plus 24i squared. But what do we know about I squared? It's negative 1, right? If this is the same as negative 1, then this is really negative 24, isn't it? Okay? So then I have 15 minus 24. Yes? So 3 plus 4i, 5 plus 6i. The I, this pi button down here, if you press it once, it brings up the menu, and if you press it again, it takes you to the next one, which is I. Oh, look, that's exactly the same thing I just got. Okay? So addition, you feel okay with addition? How do you feel about multiplication? Okay, what's left? Division. Did I say division? Or did I say addition? I don't know what I said. You know what I meant, right? Addition and subtraction you're okay with. Multiplication you're okay with. Now division. 3i over 4 plus I. Can we have an I in the denominator? I'll tell you right now, no, you cannot. Okay? So we have to take what's called the conjugate. Do you remember us talking about complex conjugates? It's okay if you don't. I do, and I'll remind you. Okay? The complex conjugate of 4 plus I is 4 minus I. Okay? What's the complex conjugate of 6 plus 3i? 6 minus 3i. What's the complex conjugate of 2 minus 2i? 2 minus 2i, right? Okay, if it's plus, it's minus. And if it's minus, it's plus, right? So if it's 2 minus 2i, then the conjugate is 2 plus 2i. Yes? Okay. We multiply numerator and denominator by whatever that complex conjugate is. Okay? The reason I do that is because that's going to help me get the I out of the denominator. Because I know the rules of distributing. And the rules of distributing say I'm going to go this way first and get 16. I'm going to go this way second and get negative 4i. This way and get positive 4i. And this way and get minus I squared. I know that this is going to go to 0. I purposely choose the complex conjugate for this reason. Okay? Because I also know that that I squared equals what? Negative 1. So this is going to become plus 1. Because it's minus I squared, so that will be minus a negative 1, which is plus 1. So what does the denominator of this fraction become? 17. Well, what happens with the numerator? Don't I just distribute? What's 3i times 4? 12i. And what's 3i times negative I? Negative 3i squared, right? Sorry. But what's true about I squared? Negative 1, so this becomes plus 3. And then the last thing we have to do is put it in the right order, right? Real part, imaginary part, over 17. Now let me show you something real quick. A fraction 3i over 4 plus I. Is that what I got? Kind of, right? It's written in a different way. This is just one fraction. This is broken into two fractions. 3 over 17 plus 12i over 17. Or in this case, 12 over 17i. Okay? Here's what I don't know. Okay? I don't know which way the computer wants the answer. So if you put one way in and it's wrong, don't automatically assume the answer is wrong. Maybe the form is wrong. Does that make sense? And it'll most likely tell you it's the right answer but in the wrong form. So try the other way. Okay? I don't know why it likes it one way over the other way, but it just does sometimes. Okay? Any questions about division? So adding and subtracting you're okay with? Multiplying you're okay with? Dividing you're okay with? Performing operations with square roots of negative numbers. You ready for that? So let's do something simple to start with like this. What does the square root of negative 9 equal? What's the square root of 9? What's the square root of negative 1? I. Okay? Then we need to go here. What about the square root of negative 8? That's not as easy, is it? Well, let's break it down into its parts real quick. Isn't this really negative 1 times 4 times 2? And don't I know some of the square roots of those? What's the square root of negative 1? I. What's the square root of 4? 2. What's the square root of 2? I don't know either. That's simplified all the way. Okay? Because what you're going to be asked to do is a problem like this. The square root of negative 18 minus the square root of 8. Can you do that right now? Can I make this negative? It's supposed to be negative. Sorry. You can't do it in the form that it is in right now, right? The only time you can subtract is when they have the same square root. Okay? So let's see if we can simplify either of these. Well, we already know what this one is because we just did it right up here, right? That's really 2i minus, or square root of 2. Can we do the same sort of thing with the square root of 18? Square root of negative 18 is the square root of negative 1 times 9 times 2. Why did I choose 9 and 2 instead of like 6 and 3? You know the square root of 9, don't you? Yeah, that's exactly right. You choose a number that you know the square root of. So what's the square root of negative 1? I. What's the square root of 9? 3. What's the square root of 2? I don't know either. Now I can do this, though, because they both have the square root of 2, right? So what's 3i minus 2i? I square root of 2. Does that make sense? We just have to simplify each of the parts until we can get it to where it's something we can do something with. Okay? What about a problem like this? Negative 1 plus the square root of negative 5 squared. Well, what does something squared mean? Times itself, right? So I'm going to go ahead and write it so it looks like it's times itself, because to me that makes it easier. Now this is just a basic basic distributing problem, right? Negative 1 times negative 1. Positive 1. Negative 1 times square root of negative 5. So square root of negative 5 minus, right? Sorry. Square root of negative 5 times negative 1. Another minus the square root of negative 5, right? And what about the square root of negative 5 times the square root of negative 5? What happens when you multiply square roots of something that's the same inside? What do you get? Just whatever's inside. Okay? Now when I go to combine like terms, I've got a 1 here. Oh, I've got a 1 here and a negative 5 here. So what does that become? Negative 4, right? And then I've got negative square root of negative 5 and negative square root of negative 5. And that becomes negative 2 square root of negative 5. But do we leave negatives inside of radicals? No. What can I do with that negative? What's the square root of negative 1? I bring it out. Okay? Negative 4 minus 2i root 5. And that is the answer. How do you feel about this? Okay? So look at the objectives again. Make sure you feel comfortable with each one of these objectives and let me know. Good? Okay, peace.